Hey everybody, this is Larry. This is me over Q3 of the bi-weekly contest 174, number of alternating XOR partitions. Hit the like button, subscribe, and join me on Discord. Let me know what you think about this one. So this one, there is actually at least two solutions, and they're similar but not quite the same idea. I'm going to describe one of them, which is the way that I did it, but I think honestly, the other way that people did it is actually much cleaner. But it requires a lot more understanding. I think the way that I did it requires less understanding, but really tricky to write. And I did make some typos that made it a little bit slower to debug. But overall, I feel like the way that I wrote it, it's very understandable. Because the core of what I wrote, of what I try to do, is tick-no-tick dynamic programming. I mean, I don't think that's the name, but I've been saying this a lot lately, or the last year or so. So I'm just going to go with that, tick-no-tick, right? Okay, so what does that mean? Well, the idea here is that, okay, let me bring up my drawing board real quick. The way that I think about it is that there is an n-square solution, right? And of course, the n-square solution will be too slow, but for illustration, I will go over what I mean. If I can find my pen. Okay. The n-square solution is just that, okay, let's say you have, this is an array, and then the idea behind the DP is that, okay, well, let's say you are at this index, then now you brute force, in a way, with DP, you brute force, okay, chop up one number, two number, three number, four number, five number, ... And, you know, without going too crazy over explanation and proofs, because, you know, if you're attacking Q3, I hope you have the prerequisite for it. Not too much prerequisite, but still, like, you know, how n-square for loops work, right? So, okay. So then the idea here is that, of course, this makes it n-square. There is this additional constraint, of course, that you have to match either target 1 or target 2 or whatever, but that part is straightforward, so I'm not going to spend time on it just yet. We'll come back to it later. But what I mean is that, okay, even if you eliminate it, right? So that, because, you know, okay, we do it one index at a time, that's fine. But not all one index is going to make this target 1. They just focus on target 1, right? So then maybe we could kind of pre-calculate, right? This is target 1. Right, maybe like this sub array will target 1, and then you have all these things that were, okay, this is target 1 and this is target 1, right? So then now it just becomes, okay, now you're looping still, and it's still n-squared just to be precise, but now you have a little bit better, the constraints are a little bit better, the constants are a little bit better, right? Okay, and this is the part where, like, maybe what I'm doing is a little bit of an overkill, as I said, but this is the way that I'm going to explain it. The thing is that, okay, let's say this is target 1, right? T1 for short, or maybe just T for short, because, okay. And then let's just also say that this one number is T, right? And this is also T. What does that mean? Well, that means that, well, this is T because that's just T. But it also means that this here, if you kind of just do like, and this is on XOR, right? If you do like a prefix sum idea, that means that this portion is going to be 0. XOR sum of that subarray is going to be 0, right? And so is this, because that's the only way that, you know, this T is going to match this T. So based on that, I created a DP that basically allows me to get, you know, have a jump table, right? Because then now, instead of looping here and then here and then here, what we can do is just, well, jump to the next one and then optionally tick-no-tick, just additional zeros, right? So that now it is saying that this combination of the initial jump plus a subarray of 0 would form one partition, right? Did they call it partition? Or whatever they call it, right? One section. And that's kind of the idea. It's a little bit weird, it's a little bit tricky, I'm not gonna lie, but that's the way that I did it. So I'm gonna go, there is some pre-processing, but I want you to go understand the core idea first. I'm gonna go over the DP. So basically I have these dimension, which is that index. It's just index, right? Index of the array. I mean, I think this part is pretty straightforward. Is target 1, just are we trying to satisfy target 1 or target 2? Because you have to hit one or the other. And then can 0. Can 0 is a really weird name, maybe, probably for certain. But it just means that can I extend with a subarray of XOR sum 0? Can I extend the previous partition, right? And that's basically it. And of course, if you just do like a very lazy analysis, index is O of n, is target 1 is 2, true or false, and can 0 is also true or false. And so, so this is O of n number of states, and because we only do O of one number of operations after that, this is going to be O of n, and ideally fast enough. But basically, he's saying that okay, if we can choose target 1, then we just we find the next section that cuts it off at target 1. If it is target 2, then we'd find the next section that's target 2. And what I have is that I pre-calculate the next index that if you're at index, the next index that allow you to have a subarray of target 1, it's going to be this index. Same for target 2. And then can 0 is just the next, given this is the current index, what's the next index in which the delta between that index and this index is going to be 0, right? And that's basically the idea. And the state should make sense. For the is target 1, you just flip, right? Because you just finish 1, you go to 2, and so forth. And then here it's always true. The only time it's not true is when you're kicking off in the beginning, because you cannot start a partition with 0. Otherwise, then you just kind of keep going, right? And that's basically the core part. This is the pre-calculation. This is a prefix sum idea. This is a prefix. This is an idea, and keep in mind that we're doing it backwards, just because I thought it was easier. I don't know if that's true, but yeah, you calculate the prefix sum from this. I'm not gonna go over it in this video because I've got this video. This prefix sum idea I've been going over a lot lately. But suffice to say that if you struggle prefix sum, work on other prefix sum numbers problems. But the idea here is that the really short idea. Fine, I'll draw it real quick. The really short idea is that okay, let's just use 0 as an example, right? You have a subarray that looks like this. Then now, if your prefix, and I say prefix, though technically we reverse it and use suffix, but suffix sum is something else, so I don't want to confuse it. But let's say you have this subarray, and the XOR sum of this subarray is x. So then now, if you want to find the last time, if you want to find a subarray in which the XOR sum is 0, well, then that just means that this chunk has to be x, because because this subarray, the sum of these subarrays, 0 XOR x is going to be equal to x, and so forth. I'm going a little bit fast, I know, but just work on prefix sum problems, right? And anyway, that's what it looks like. I pre-calculate it, or I store it down, but before that, I make sure that all the indexes is in place, and that's basically it. I made a lot of typos during the contest, and including even this one. I just kind of got a little bit sloppy and put in the wrong place, and put a lot of silly things. But otherwise, that's basically the idea. I would also say that for me anyway, this is the harder problem of this contest. So even though it's a Q3, I consider it pretty tricky for me. And that's it. That's all I have for this one. Let me know what you think. It's going to be linear because this is linear, as we kind of talked about. And this is just a loop, right? So a loop and lookups. So yeah, that's it. I'm going to make it slightly smaller so you could see the top and the bottom. And that is it. Thanks for watching, and you can watch me solve it live in the contest now. Phrasing it, and maybe I'm misunderstanding it. Okay, maybe not, but it's just so wordy became a reading contest instead of a solving contest. But okay. integer array nums, two distinct numbers, target 1, target 2, the partition of nums puts into non-empty box. That covers an entire array without overlap. A partition is valid if the bitwise XOR alternates between target 1. What? Number of okay, mod. So basically, we're trying to find a partition in which the thingy is equal to 1 and then 2. Is there a DP? Is it index XOR sum math? No, it's XOR. It's not an AND OR. So. I mean, there are multiple choices, right? So this can be n square. How do you not do it n square? Ten to the fifth. What's 10 to the fifth mean? 20. Yeah, because there's a lot of 1 prefixes, right? Then how do you do it? How do you loop all of them without? Yeah, I mean, I see it, but I don't know if that's easy though, and I don't know if it's computationally cheap enough. So you have index, fine, right? Maybe we have a prefix sum. Right, and then now we have, how did I get k from? Ref. Maybe it's a boolean, but I'm trying to name it T1 or T2. Or is target 1 maybe? And then the idea is that maybe I need one more state, but okay, so we're at the current index. This may be easier doing backwards, but 3,000 people solved this? I mean, I know how to do it, but it's just so prone to off by 1 or something. I don't know. Yeah, maybe I'll just do it backwards. I mean, it's the same thing, right? So I don't know. So basically, okay, so then now we do this, right? Previous T1 is equal to previous T2 is equal to and then previous 0 is equal to right? And the idea here is that, okay, so then now we have this thing. Let's just say and then now you have okay, so that's afterwards, but then now, okay, so if current then previous T1 of index is equal to prefix of current to target 1, right? So now this is going backwards. Yeah, okay. That seems right, maybe. Then now to do this backwards, which is a little bit messier. Now going forward makes more sense, actually. Okay, then I do. And this is wrong anyway. This should be nums. Okay, let's print some stuff. Okay, so 6. What was it saying? Prefix. We have 0, 4. That's not right, right? Why is it 0? Index. Huh? Maybe this is off by 1, but that still doesn't explain it. Okay. Okay, so 3, right? So why is this? Oh, because it does it again. Okay, that's fair. I forgot that it can do it again. So then here, okay, maybe. So then previous of 0. Mm, 4, that's 5. And 2. And 4 again. I know that's right, actually. Okay, that did nothing for me to have confidence about. Okay, so then now is target 1 now. Okay, try to cut off target 1, right? So that's total to do f of previous t1 of index. That's if and then it is either, well, this is now false because then now you're trying to get target 2. And maybe can 0, maybe, and then now this is true because then maybe we could just go 0. Is target 1 and then true, right? Maybe if is target, if it's not, is target 2. Oh wait, no, that's not right. If it is target 2, then something like this, but it feels wrong. I feel like I'm off by some stuff, and maybe this is off by 1 anyway. But it feels off because nothing sets this to false. I guess other than the beginning, when you have to choose the first one. Okay, maybe that's fair. I don't know if I believe that, but true, false is target. Oh, whoops. That's why I had not. I'm confused. But okay, not quite right. Oops. But hopefully this is the right idea, though. Because basically you cannot do n0. Okay, so it goes from 0, true, false. Okay, it goes to -1, which is not very helpful. Do we still have -1? Oh, that's not what I meant. Okay, it's still not great, because that means, did I set up my things wrong? Okay, so now it's saying that from 1 it can go to 3 to hit target 1. 0, 1. Something feels off, even though I feel like I'm set up okay, but I am definitely wrong on stuff here. Even this is technically wrong. No, this is just an initial thing. That 0 is actually right, but okay. So 1, 2, 3 is 1, so it should go to 2. So index is Alright, what are you doing? Let's just print prefix. Okay. Let's print prefix progressively. Okay. So then starts at 0 at the last thing, 4 after 3, 2 after, oh no, it's 5 after 2, which is right. And then 5 XOR 3, it's going to be 6, okay, 6, and then 4, right? So this entire prefix is 4, right? It's missing an index, but why? It's missing an index, that's why. So at 0 it is 4. No. At 4 it is 0. That's the important one. Okay. But then it doesn't check this thing again. Maybe it should be here. No, that doesn't. It feels off by 1 in either case. Maybe there's an infinite loop. Yeah, I mean, if you do it by yourself, then there's an infinite loop because it just added stuff to itself, right? Huh, and why? And then it's -1. What am I doing wrong? I mean, this is right in concept. 1 goes to 3, which for a target of 1 is not even right. Is it right? No. I am just dumb today, maybe. And this is a medium? What am I missing? Is there an easier way? I feel like what I'm doing is not easy, and I knew that going in, but prefix is right. So then what is wrong with this? This is just wrong, right? Because it's always the previous index. Because we don't do anything with it. Why? What am I doing wrong? How did I not get the... I guess I'm doing it backwards, that's why. Usually I don't do it backwards. But that's an excuse. Alright, 0, 2... okay, maybe I did do this wrong. Maybe I did do that wrong. Okay, but now it's 1 and 4. 1 is right, but why 4? Okay, 0, true, false. It goes to 0, 2. It's doing target of 2, but I can also do 0. So found 1, okay. So why do I think there's 4 on part 2? Okay, so goes to 1, true, false, okay. Goes to 0, 2, false, true, okay. Okay, so 0, true, false is 4, but 1, false, true is... What does that mean? That means that I can go 1, 2, and then 3, right? Why is it 4? Okay, 2, false, true is 2. That's probably wrong. Because at here, you are doing target 2. Oh, because you can do... No, I mean, it's different interpretation, right? So here, it's 2 is right. One of them is extending, and then the other is not extending, and it's starting force 2. Where did I get the 4th one though? From 0, true, false. Okay, so from 1, so we already did 1. That definitely, this is wrong as well. This is maybe right, but this is wrong. Why is this wrong? Because here, plus 1. Why is it plus 2? Because it caused this twice. One false true. 1 it is on target 2. I think I see it because am I confusing a state? So this is trying to partition on 1, right? And then this is partitioning on 2. And this is continuing the streak. All right. Yeah, so it's calling this twice, but why? So 1 false true means that we finish this. We are at target 2, and that we can't do 0, that's fine, right? So then now, that means that we can either continue or well, I'm wrong anyway. This is not false, this is true, that's why. Was that why, you dumbbell? I can't believe that's such a easy, I don't know how I missed it, but okay, fine. Am I good? I don't know, YOLO submit. It may not be, but okay. That's such a, I don't know, that was so hard for me. Real guy, wait quickly. I mean, I had a typo that cost me like 10 minutes, so maybe that's it. But and then I don't know, I was just way off on that one, like a lot of silly things. All right, let's look at Q4 minimum edge. Thanks for watching, everybody. Hit the like button, subscribe button, join me in Discord. Let me know what you think about this problem, this contest, everything in between. Stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye bye.